think I should be live now. Hey everyone, how's everyone doing? Let me shrink my preview. Nah, I won't be able to tell. See if I can put my two windows side by side. Yeah, should be fine. Let's hope there's no drop frames. I need to do motion to do drop frames, so we'll see if anything happens. How's everyone today? Hopefully pretty good. Oh, there's something I might need to get in order to CAD. Yeah, I'll do it a little bit later, I guess. Wouldn't worry too much about it. So how's everyone today? Oh, shoot, I was supposed to put this video live. Whoops. I'll put it live tomorrow morning. So, yeah. A little bit of a spoiler alert. This is the video that's going live tomorrow. How's it going, Adam? So far, no drop frames, which is a good sign. Sorry for the background noise, but you're just gonna have to deal with it. I am 3D printing some stuff. So my 3D printer my printers have been dormant for a little bit. Oh, are you gonna record? Are you gonna leave to record? Because that's totally fine. Just wondering. So this is the kind of stuff I've been printing. This is a failed print. So as you can see, it came off the bed a little bit. See a little ramp? But this kind of stuff, so if you have a guess as to what it is, let me know, but it is rock solid, can't break that. Actually, I guess I could show you a completed print. So here's a completed print using this pink PLA. Funny story, this pink PLA comes from an Amazon listing. I think it was $18 for a kilogram of pink and a kilogram of purple. I guess because, you know, 3D printing skews male. And so I got 4 boxes of PLA, 4 kilograms of PLA for under 40 bucks. What's this, PLA purple? So this stuff and this color too. So pink and purple. And it's just now occurring to me that purple is kind of the channel color. So for something that's going to be featured on the channel so prominently in the future, I probably should have printed it in purple. Well, now I'll know. Not tonight. Already released one video, haven't recorded any more. Oh yeah. Tell me about not recording enough videos. That's been my life recently. I'm basically doing a lot of work for school. I'm getting some PCBWay videos done so I could pay mortgage. Doing podcasts because I have a self-imposed schedule every 2 weeks. So yeah, that's pretty much that. I do want to show you guys something. I'm going to go upstairs for a moment. Let's see. Hang on a second. Remember this from last time? Well, be right back. So I'm going to put this here. Working on a website. Oh, very nice. I need to put more work into my website. So everyone is going to be able to hear me, but I'm just going to be upstairs grabbing something to show off a little bit. So going up. Here we go. Thankfully, it's not far. I've been meaning to do a video on this for a little while, but I have not, quite obviously. All right, we're back. So this is a Tupperware. Actually, I can probably demonstrate, except I'm not happy about one aspect. No, I won't demonstrate. Okay, so this is a battery maintainer that I designed, and by designed, you'll see how simple it is. I just have to be careful when I open this because I think there's wires connecting this to the rest of it. Yes. So, here we go. So inside, all it is it's this DC to DC converter, and it's powered by a laptop charger. And basically, you just have this one off-the-shelf sort of, a volt and current meter, and this DC-DC converter, and I've set it to like 13.5 or 14.2 volts. And basically, you plug this into a lead-acid battery, plug this into the wall, and it maxes out, I think, at 2 amps. And so, yeah, it'll maintain your battery, when it's like super cold outside. So pretty cheap. How's it going, Thomas? Welcome to the stream. So yeah, I'm probably might be refining the CAD work on the for the case for this today. But yeah, these laptop chargers, you pay very little money. They're already CSA approved and whatever. You could probably find one in the trash or on the used markets like Facebook Marketplace or Kijiji fairly easily. Plug this into the wall. This gives you 19 volts at 3.42 amps, and this I've limited it to, I think, 2 amps. And basically at 2 amps, you can leave a lead-acid battery on charge forever and it won't damage it. So yeah, this is my solution. How's it going, Johnny? Welcome to the stream. Again, if you hear noises behind me, it's because I'm 3D printing stuff, and my most reliable 3D printer is also my loudest one. So it is what it is. Yeah, the case is not 3D printed. That's why I might have to, might do some CAD today to design the case. I also want to add a switch too. I don't know if you know, but if you plug in a circuit that has capacitors. So here, you see there's these output capacitors here on this module. If you plug in a circuit with capacitors onto a lead-acid battery, it will spark. And a automotive lead-acid battery is not sealed. In fact, let me go grab one and I'll show you what I mean. And the problem is if you discharge a lead-acid battery, by using it. So like, let's say you have a parasitic discharge in your car, and that's why you need to charge it up, with a battery maintainer. Well, you're creating hydrogen gas. There we go. Typical car battery. This one's from my my Civic a couple cars ago. But right here, there, and there are vents. And so if you plug this in, positive and negative, and it sparks, which it will if there's capacitors, then you can light any hydrogen gas that is venting. I have a request triggered by my podcast. Sure, shoot your request. I'll listen, and maybe I'll take it in notes. Who knows? So everything that plugs into a lead-acid battery that has capacitors on it or outputs a current or whatever should have an on-off switch, and you should have to plug it in and then flip the switch. So that's another design improvement I need to do here. Can you control a fuel injector using ESP32? Indeed, you can. In fact, ESP32 might be strong overkill. you could probably do it with a with really crap microcontrollers. You could probably do it with like a PIC, you know, an early PIC. Hang on, I'll see if I have an injector here. Basically, a typical injector pulse is somewhere between 2 and 20 milliseconds. It's not particularly fast. Oh, and my box of goodies has moved. No, I won't be able to dig out a fuel injector right now. Unless it's over here. No. No digging out fuel injectors. But yes, you can definitely control a fuel injector. Yeah, open. Yes, I am alive. I'm a little bit out of breath going up and down the stairs, but yes. Yeah, open SCAD is very like, you know, it's like, you have to do math. I'm not an open SCAD guy. Open SCAD is painful when you try something not trivial. Yeah, I agree. Yeah, you know, good on people for having open SCAD skills. That ain't me. That's definitely not me. Did you release a video today, Vero? Everyone who doesn't know, Vero is my lovely wife, and she has released she has a reaction channel. You requested a topic in the podcast, and well, a fuel injector guide is my personal request. Oh, it's your week off. Okay, fair enough. I'm going to take note of that, how fuel injectors are controlled. The only problem is there are two different control schemes to a fuel injector, and I only really know how to do one of the two. Like, the schemes are simple, but the programming is a bit more complex. One requires you just pulse the injector on. It's called saturation mode, or saturation mode. You just pulse it on and you pulse it off. That's the way basic stuff works. But your injector needs a specific resistance, or you need to add a resistance in series with your injector. The other method is a peak and hold, where you actually drive your injector with super high current to open the pintle as fast as possible, and then you drop the current and hold it for the rest of the duration. That one requires a really good feedback of how much current is going through, and that one is that's a bit over my head for programming, but like, it's not super complicated. You just need to program it. Build a panel maker for 1515 extrusions. Nice. Designing an enclosure for my 100-watt flashlight in OpenSCAD. Very nice, very nice. Chokes. Yeah, chokes for a carb. Chokes is very simple. You just limit the amount of air. So usually it's a throttle plate that shuts. I might have a carburetor somewhere. Hang on a sec. Carburetors, I might have some because I'm into remote control cars, and I have one that burns nitromethane, and it is carbureted because just the idea of putting in tiny little fuel injectors and on an already expensive car, I mean, it gets a little wild. Oh, this is full of junk. Oh, there we go. That could probably work. Let me just get a paper towel and wipe it off. I didn't expect this live stream to go this way, but that's fine. So it's full of sawdust because it's in my dirty side shop. Give me a second here. And here. So there's a carburetor. That's a very small carburetor. This is for a 3.3 cc engine. So a 3.3 milliliter, right? Cubic centimeter. No, that doesn't make sense. Whatever. Tiny little engine. So here's the throat that goes into the engine. I need a black background to, hang on a sec, to make the camera deal with the exposure. Like that. No. No. How's it going, Franco? Is this blacker? That's pretty black. Okay. So yeah, here's your carburetor. So this is the engine side on that side. And this is the air filter would sit on top here. Fuel comes into this pipe here, this guy right here. And then here is the needle valve. I believe this one here, if you turn this whole assembly, that's just more fuel or less fuel. And then if you turn just the slotted part, that's to more or less fuel at idle. And if you look on the inside, if I slide this, that little cylinder comes out of the way. And there's a little needle inside there to feed the fuel. Very hard to see because the lights aren't lined up with the camera. But there you can see right through. So there we go. So basically you just slide this open to allow more air, and the higher airspeed should suck more fuel into it too. So in order to choke an engine to make it more rich, have more fuel, make it easier to start, you can just partially obscure the opening here and you crank the engine, and because it can't suck so much out of this section, it'll just suck fuel directly through in here. Because there's no fuel pump on this specific two-stroke, although you can have most two-strokes do have a most of them have a fuel pump. This one actually just uses exhaust gases run back into the fuel tank in order to push more fuel in. But yeah, this thing is as simple as it gets, and you know, you could conceivably 3D print something that would work as a carburetor. You would just need some, you know, heat-resistant materials for it. But this one is made of plastic. This one is probably nylon and probably glass fiber reinforced. And they injection mold this, and then they drill holes down this way, so you get the hole. Oh, actually, here's the idle screw. Whoops. So this is the high-speed fueling, and this is the low-speed fueling here. So yeah, they just cast this, and then they drill down this way, put a plug, and then drill down this way, and put a plug so that you can have all your, and this way too, so you have all your fuel passages. So yeah, pretty cool stuff. Printing a carb, as I have a nitro engine without a carb. You know what? Just go on AliExpress. They sell these kinds of carburetors for very cheap. You can get, there's a company called Red Cat or HSP, and they make nitro engines, and you can just buy parts from those and adapt them to your needs. But yeah, printing a carb would be cool. I'm going the other way. My thought is that I want to convert. I have a 1960s outboard engine, outboard motor. It's an outboard motor assembly, has an engine in it. But I want to convert it from carburation to fuel injection. And so I think it would be really cool. Instead of the points, first of all, instead of the point system, I would go completely electronic ignition, and then after that go electronic port fuel injection as well. That would be really cool. Apparently, the only difference between my 9.5 horsepower and the next model up to 15 horsepower is the size of the carburetor. And so if you do fuel injection, then you can just increase the pulse width of the injector, and then you'll be doing the exact same thing as a carb. You'd be giving it more fuel, and then away it goes. Whoops, knocked the camera there. So yeah, So this is one of the options we can do today. We can model a new, an actual case for this prototype. We can talk about 3D printers and stuff, how mine bit the dust this week, trying to print parts. Look, the nozzle ate. See if I could show this properly. The nozzle dug a hole in the bed, and it's so bad that it went through the magnetic part. So the magnetic part on the bed needs to be replaced too now. And I don't know if the aluminum is damaged underneath, but I hope not. I can also film a live mailbag, that's always an option. So far it looks like we're not dropping any frames, so we're in way better shape. Motorbike had a carb like that, 90 cc. Well, this carburetor is for a 3.3 cc. In fact, I might have the engine kicking around somewhere. Let me bring this back and I'll look for the engine while I'm there. Oh. This battery must weigh about 40 pounds. It's pretty crazy when you realize a lead acid battery is literally filled with lead and acid. Mostly lead, by weight at least. Let's see, where would I have put that engine? There's because I have a scrap engine and one that's in the RC car still. Not in here. These nitromethane engines are so picky that it's quite easy to blow them up. And plus, I mean, they rev super high. They must rev at, I don't know, 40,000 RPM, something like that. Nope. One thing I miss is having an RC car, but I don't really want to spend money for the name brand RC cars. They're so expensive. Oh, here's the head. Well, I have the cooling head. I don't know about I feel like I may have thrown away the rest. I do have a different one. Give me a second. Still working on it. Yeah, it's one of those things I may have thrown away. Well, bring you another one at least. So I think this one is a 2.5 cc. So I gotta catch up with chat. How did that happen? I also filmed a mill bag. Nice, nice. Running at 13% on 20% because I can't get the lower fuel. Okay, okay. So this is the cooling head from one of those 3.3 cc nitro engines. So there you can see in the very middle there, you can see the glow plug. Maybe you can't because of the focus. Focus, there we go. In the very middle there, you can see a little filament that lights up the nitromethane. Here is the cylinder block and crankcase. I'm trying to think this, maybe it's a 1.6 cc. I'm not sure. Maybe you can see a little piston in there. Go up and down. Here's the back portion. So there you can see the counterweight on the crankshaft and the connecting rod. So that connecting rod connects to the piston. And then here is the cooling head for that one. No glow plug in this one. So there we go. And then you've got the flywheel, which is relatively heavy. So the flywheel would hook up, pretty sure, over here. Probably. I don't think it goes on the back. I think it goes in the front. This way? No, it can't be this way. It's be this way. Feels like there's missing something in the middle here. And oh yeah, here's the other end of the crankshaft. So that little slot there hooks into the little end of the pin there. Sorry about the knocked camera. Focus. There we go. See a little pin at the end there. So that pin hooks up into this little spline here. I basically stopped playing with gas-powered RC cars because I just can't afford it. Like, everything is so expensive. There's the exhaust. It's just way too expensive a hobby. And they honestly don't run great. They don't have feedback. They're not like a car. When something goes wrong, the computer puts on a check engine light. Oh, there's a throat for the carb. The engine doesn't like throw up a check engine light and starts running like a bag of poo, and then you can just, you can limp it home, and then you can check the codes and then go after whatever sensor is freaking out or whatever the engine's doing mechanically. It's really like when it goes. It just blows up everything, and then you have to replace parts. And honestly, like an ATV, like an ATV engine, the parts in that engine are roughly the same price as these nitromethane engines. So like a piston for this thing would probably cost like 60 some bucks, whereas you can get a nice aftermarket piston for an ATV for 60 some bucks. The cylinder head, this part here is probably over 100 bucks. And so it was just way too expensive. It was lots of fun while it lasted, but I'm pretty sure the one that's in my car right now, the one that's in my RC truck right now, I think it's blown too, and it's just been years. It's just been sitting there because it's way too expensive to fix, and to buy another like full engine is like $400 or $500. It's like, it's too much. Yeah, it's very cool, Franco. This is why I got them in the first place, because I thought it was super cool. But yeah, they're so unreliable. And honestly, like I just bought so I have a 9.5 horsepower Johnson Evinrude from 1969, something like that. And I actually have one that came with my boat, which it's been with me over 10 years now, and I don't really make time to go out and use it. But my boss at the time found me a used one for parts as well, and it cost me like $100. So the one came with my boat, the other one cost me $100, and now I just bought a complete one in running shape for $200. So now I have basically 2 working engines and 1 parts engine. And it's those 3 together, they're full size 9.5 horsepower outboards, are the same price as just replacing this one motor on my RC car, which I can't even run around the lake. You know what I mean? It's like, it comes to a point where I find this technology super cool, but I would rather spend like a lot less money, and really like it is a lot less money, and run something like this Beta FPV, not this. You could power it with something like this. This was like $40. So this one has a little bit less power than that 3.3, but this thing will last nearly forever. And you can buy some of these for the same price as the 3.3. This is like $500. If you buy a $500 motor, you'll get like 4 times the power of this thing. So it's like, yeah, exactly. You got it. How's it going, B-dubs? So I would much rather go electric. And in fact, I just have to get a bit more courage and some time on my hands, because I want to convert one of the parts 9.5 horsepower motors into electric, because I already have something that'll kind of do the job, which is this guy, this motor. But for not much more, I can get so this is a 500 watt motor, I can get a 2000 watt motor, and it'll be roughly this size. And so this was like 60 some bucks, I think 70 bucks. But the 2000 watt motor and driver, I believe it's 160 bucks, and it's this size, so any mountings I make for it will transfer over. And then the outboard motor has the gear case and everything I need, and then I'm off to the races. Batteries are going to be really expensive, mind you. That's another aspect, but I mean, why would you spend 500 bucks on this kind of stuff, which is fun, when I can spend a lot less money? Like for 500 bucks, I can get a battery solution and a motor and power my frickin' my boat around the lake. And I dare you guys to go look on my second channel, SE Condary, and go check out the video of my boat going around the lake. It's so peaceful and quiet, and it's tons of fun. And that's just using a little trolling motor. With these kinds of motors, you can go, fast with it if you need to, and you can go slow with like the same efficiency. It's crazy. So that's why I kind of abandoned these nitro engines. They're a lot of fun, but I just can't afford them. And the price to performance ratio, yeah, the batteries are expensive, but it's not too bad. Here, let me show you what I have in mind. We'll switch to the screen. Since you guys are kind of sort of like the dedicated few that come here. Express, like so. And then you have 18650s. So here's a thought. And VRUZend, I think that's the company. Yeah. Nitro from a mag 10 years ago, and it's only fast a few years I could afford to run it. Yeah, exactly. Yeah, an electric is quieter. So VRUZend, I actually contacted them because I want to buy 4 kits from them. But basically they make these kits, so these battery kits, and I want the upgraded kit, obviously. Oh no, out of stock. Well, that puts a damper in my situation. But anyways, they have these kits where you build your own packs. See, they're like Legos. Actually, if you want the best example, Julian Eilert, BRUZEND. There we go. So, watch on YouTube. So Julian Eilert, oh boy, I don't know how loud that was. So Julian Eilert has the V1 kit, and basically he built himself some packs out of them. And so the thought for me is I want to get 4 of these packs. And why 4? Well, no, I'll get to, Thomas, I'll get to it. Why I don't want a spot welder. I do want a spot welder, but not for this. So you get 60 terminal caps. That means you can make a pack with 30 cells, right? So the reason why I want 4 of these packs is shipping is almost the same price as a pack. So it's 42 US. Let's see, 42 times 1.35, something like that. So it's 56, 56.70 Canadian, and then I have to add the shipping. So it's more like, it's like 42 plus another 40, okay, times 50, well, so 82 times 1.35. So it's 110 bucks for one set, but I can get 4 sets for about 300 bucks, just under 300 bucks, because the shipping doesn't stack as high as the regular thing. Okay, so you get a whole bunch of these. So when they're here and in my workshop, I can have them in a 3-cell configuration in series, and I can use them, you know, as a bunch of 12-volt batteries to store solar panel energy. So it can be solar storage here. When I need to bring them onto the boat, I can wire them, those 12-volt packs, into as many series packs as I need to bring the voltage up, so I can use a high current, high voltage motor on the boat. With a spot welder, you cannot change the combinations, right? Once they're on there, you have to like rip the nickel things off, so that's not great. But also, I can custom make with these things, because the distance between the posts are constant. I can custom make strips that are like copper and thicker, so I'd be able to do higher current as well. So that's the thought. And then 18650s, I do have, if I go over here, I'll have to go check on my saved sellers. AliExpress, and then I go to, gotta sign in. And then I have to go to wishlist. I'm sure I've wishlisted him. Give me a second, I'll find you a seller. These? Currently unavailable. Uh-oh. I'm not liking this. Well, shoot. Okay, can I not have the mobile? And then text this, copy. Just gonna paste this over here. Sorry about the ghetto-ness here. I have a drone to play with that someone broke the upper part of the frame. Haven't got the time to look into replacement. Got it for free. It's supposed to be 2K new. Make a new drone out of the parts, yeah. Top shell, yeah. Okay, so these. All right, so you got these cells, and it wasn't even these, it was some other ones, but from this company, Lands HD, where you can buy like a ton of cells, yeah, like 40 cells at the same time, and then I can just, you know, make custom packs, however many I need. And if you look at people, see, it's 3298 milliamp hours, 3310 milliamp hours. So like, they're good cells. And then, you know, can make my own packs. So that's the thought. The lowest common voltage around 12, swapping individual cells. What about balancing? So yeah, so because everything's bolted together, I can get 3-cell BMSs and put them together, and you can unbolt the BMS and then get a, you know, if I need a 60-volt BMS for, here, let me show you. Let me show you. 2000 watt motor. Like this here. Yeah, VVOR. There we go. So if you look at this, that's more a bigger one. Yeah, this guy. So look, I can get a 48 volt, or I could get a 72 volt, right? Depends on what I'm willing to spend. But that's the thing, I can reconfigure those 12 volt packs with relatively cheap battery management systems. I could just unbolt the battery management systems and bolt them to a, you know, a 72 volt battery management system. So that's kind of what I'm saying. I can run a whole bunch of packs individually stacked here in the workspace, and then I can easily reconfigure them to be 72 volts or 48 volts, no matter. And what's nice about that is the same cells, they can go with me, because the other option are lithium iron phosphate batteries, which I am totally for. I wanted them. But the thing is that they're only really a good deal in 100 or 200 amp hour configurations. And if I want 72 volts at 100 amp hours, that'll be a massive, it's going to be like a huge pack, 72 volts at 100 amp hours. But then also, it's going to be so expensive. It's going to be like $3,000. And I'm not looking to spend $3,000. Yeah, but the 18650s, I make them into packs, right? And because everything is bolted, then I can reconfigure. And so let's say I have 3 big 12 volt packs. If I want to go 48 volts, I can't just put those 3 packs into in series with each other. But I can split the big packs in half and then put those in series, and so on and so on. So that's the idea. And so this Vrusen kit is really good. I wish I could make my own solution, but you can't. They have custom parts, and the custom part is, oh, you can't see, but inside the cap, I think Julian Eilert shows inside. It's like a, yeah, there. It's like a little spring. It's a little flat spring, and there's a bolt going through it to, hook up to the bolt there. I feel like he's got a Gen 2 pack as well, but it's just, I just wish it wasn't so expensive to ship things up to Canada. Yeah, this product is expensive. Love the idea. This it can add cells and do everything. So that's where I'm falling right now, because there's just, at this point in my YouTubing, there's no way I can afford to get like a 72 volt pack and a 24 volt pack and a whatever. It'll be fairly light if they're 18650s, but with lithium iron phosphate, there's no way. Because a Life PO4, and let's go 100 amp hours. So these 100 amp hour cells, where are they? Well, here, see, look, like, this is what I'm talking about. So if you look at the price here, so 235 plus 134. So it's $369 for 40 amp hours. But then if you go for 100 amp hours, look, it's $100 more, less than $100 more for more than double the capacity. So that's why the deal is not very good. But here, I'll show you how heavy these things are. So the 100 amp hours, 100 amp hours, 9.2 kilos. So 9.2 kilograms to pounds. So it's 20 pounds per 12 volt battery. And so you need to modify. So for 48 volt, which is the lowest voltage you're going to probably run. So it's 20 times 4. And so you're looking at 80 pounds of batteries. And that's no wires, nothing. And then if you want to go up to a max, let's say 96 volts, that's twice that. So you're looking at 160 pounds worth of batteries. And if you're looking at, $450, you multiply that by 4 to get a 48 volt system, it's going to cost me $1,800. It's just way too much money. I don't have $1,800. And so, yeah, I'm going to spend like $600 on 18650s, good quality ones, and you know, enough kits to last me quite a while. But then it's modular, and let's say I have a sponsor that wants to chip in and send me batteries, I can expand my packs that way. So that's the thought, at least. But yeah, this is the basically LANZHD. That is the seller I've settled with. Oh yeah, and I forgot, they even have these pouch cells. They're just less convenient to hook up together. No, they're relatively high discharge. It's like even like 12 of these, you could put in metal containers like ammo boxes and run from box to box. Yeah, that's exactly it. You can find cases easier. I have an ammo case here, but they are buyable. You can buy ammo cases here in locally in Ottawa for not very much money. So yeah, just all these things are just things I'm thinking of, but it all costs money. It sucks because when you become a big enough YouTuber, companies kind of like fight over trying to get videos done on your channel, and so then you get more opportunities to make bigger videos, and you know, you have a return on investment and all sorts of things like that. No such thing with a small channel like mine. So it's all out of pocket. So I have to make sure that whatever I do doesn't serve a purpose, it serves multiple purposes, because if I amortize the cost over, you know, 10 videos, it's not so bad. Yeah, I agree. I would rather lithium iron phosphide, but it's not doable. It's not doable for the amount of money I can spend on it. Can you guys hear the 3D printer in the background, or not really? Actually, I've been wondering that. One day I'll have 100,000 subscribers, and then I'll get a lithium cell supplier. Just to give you an example, I contacted Vruzend, and I didn't even say, well, look, the GoFundMe is one thing, but the fact that basically I don't even have high enough viewership to get like a significant like thumbs up on my freaking community posts means probably the conversion rate for GoFundMe will be pretty low. Let's be honest. And I do have a version of GoFundMe already, which is Patreon. But I contacted Vruzend through their website, and I didn't even say like I'll do a video on it or anything. I just said I want four of these kits. So I'm spending, you know, let's say 42 times 4 on your website. Do you offer any volume discounts? And they haven't even answered me, so I'm guessing the answer is no. I just thought maybe I would, you know, save a bit of money, but it is what it is. Maybe in the summer, if I wait, in the summer, maybe I can drive down to the States and pick it up, so I save like half the shipping cost, but that's only if I'm going that way, because it's still very expensive. Okay, it's not annoying, that's good. I wish I had a little camera set up there so you guys can see what I'm printing. Maybe I'll put that, oh wait, I need to put the, I got a little bit of a cough too, so if you hear me mute the mic, that's why. I'm gonna go to my Google Docs, and I'm gonna go to my ideas section. Video ideas. Okay. Oh. Okay, controlling an injector with a microcontroller. That's one idea. And what was the other thing? Oh yeah, ESP32 camera for 3D printer to show on stream, possibly. There we go. So yeah, how's everyone today? This probably won't be like a super long stream. You might hear the 3D printer more because I'm right next to it now. Just making sure I'm not running out of my pink filament. I have upgraded my X3A a couple weeks ago, 3D printer, but I haven't done anything with that yet. Man, I wish I could just 12 pieces. Yeah. I wish I could just pull the trigger on stuff like this. These are 10 amp hours? Yeah, 10 amp hours. No, they're 10 amp hours. I wish they had really big ones. Maybe they do. Let's check. Here, they have lithium iron phosphate too. They do have lithium iron phosphate pouch cells. How big are these? 8 amp hours. Having lag, 1:30 behind live. Otherwise, stream just buffers. Oh, anybody else have that issue? I think I'm not dropping any frames, so that might be on your end. Ooh, 26 amp hours. 20 amp hours. 50 amp hours. Really? Yeah, but they're super expensive, right? 5 pieces. Yeah, so if I want, I need 8 to make 100 amp hours. Yeah, it's still too expensive. Dang it. All fine over there. Because yeah, this would be pretty neat. I'd be down with that. That'd be freaking dangerous to ship this though. Let's see. Let's see how people got them. Nope, no feedback. Nobody bought them. Or nobody. Usually you can see how many were ordered. Let's see if anyone bought these. One order. Yeah, these are fancy. Oh, okay. No damage. Both banks, 3.28 volts. So it's shipped with in a plastic container with tape over the tabs. God, I wish I could reach out and ask them, but it's gonna be a big fat no for sure. 300 bucks. One day, you know. I'm pretty happy with my sponsorships I'm getting through PCBWay. But in order to pay my bills and to do expensive things like this, it would need to go up. But I'm good, just hanging out with you guys all the time. All right, let's see. Oh, I'm probably going to be streaming on Monday as well. Just so you guys know. Monday as in on the Twitch channel playing video games. Test box. Oh, nope, that's not what I wanted. Turn that to read only. Turntable. Oh, turntable project. I just ordered some parts for it, so at some point the turntable project's going to be done. Let me just put that in my video notes. Project turntable. There we go. So that's going to be nice. Prop tester, need to do that again. Project snow speeder, that's, well, winter's almost over, so Project lures has nothing. Sandbox, what was this? It's read only now. Oh yeah, this was my remote control boat. It's good. I don't know. Probably in the snow speeder. Yeah, look at that. I have freaking 4 files for my snow speeder because I didn't know how to use Fusion at the time. Fin posting, whole post support. I don't even know where my stuff would go. Did I put it in here? This is where I designed a skimmer basket for my pool, but the software has issues rendering it. It's like too big. Charger bay, is that separate? Yeah, midsection bottom. This was the this is for the video that should be coming out tomorrow then. I actually don't know where I put all my stuff. Maybe it's gone. Maybe it's in the snow speeder. I don't know. These are the new ski designs. Component 2. Oh, that was the old ski. Bodies. I have no idea. It'll be version 2? Version 2, I think. This is where all my parts are for the snow speeder. Oh yeah, this is the giant duct that I made for a big motor, split in 4. I don't actually know where all the stuff is. Oh. Yep, this is all designed by me for 3D printing. Actually, here's a good question. Where's my OpenRC project? Oh, I was looking down here. I have all these things. Whoopsies. OpenRC project is here. I think Thomas, you're pretty new here. This was my project to a fully 3D printable RC car. Still working on it, mind you. It's not even close to being done. It's editable. 2020 parts. I got a lot of stuff. My LED. That's a PCBWay project that I haven't filmed yet. It's done, but it's not filmed. Oh, does this not have anything? Oh, well, it's nothing. LED? LED's nuts. This is my humor. Oh, actually, I disagree. Fusion 360 is actually fairly simple to use. I find this much easier than OpenSCAD. It's very, very visual. Missing some bodies here. There's like the macro pad holder. I don't know what the duct was. Well, that's definitely not a duct. This is for the banana box. That's not that. Yeah. FreeCAD, I have FreeCAD installed. FreeCAD is extremely difficult to use, in my opinion. FreeCAD is just, it doesn't work the way my brain works. Fusion 360 is free to use. I would highly recommend you download it and try it, but I find OpenSCAD very difficult. I find FreeCAD very difficult to use. I should probably install the latest FreeCAD and try it out. I do want to switch away from Fusion 360 because it's bothering me that they just keep updating everything, and every update they just remove a little bit more functionality. And FreeCAD is the opposite. They're constantly adding stuff in, so I should probably just install latest FreeCAD. Let's see. All right, folks, in the chat, let me know something that I should design in FreeCAD right now. Yeah, FreeCAD is much harder. In fact, I'm going to try it right now. I'm going to flip you guys to the webcam so you guys can take a look at other things while I install FreeCAD. The moment that FreeCAD has me make an account, though, I'm out. The whole reason is so that I don't have to make accounts. Well, let's see if we can figure it out. I mean, the thing with FreeCAD is their social media presence is pretty strong. I think you could just complain to them on social media, and they're gonna be like, "Oh, you can suggest, you know, stuff." They're still in freaking beta. Next. Install. Tinkercad is perfectly good. Yeah, I like Tinkercad. It's a bit... Last time I tried it, it was a bit basic. I really liked the idea of making a 2D sketch and then extruding it upwards. But we'll see. FreeCAD 2.0. I do have FreeCAD, but which one do I have? I don't know which one. I have 0.19. You find KiCad easy to use? I find KiCad difficult to use. I do use it, mind you. But I think in terms of user friendliness, KiCad is not particularly easy. But here, let's try. So I'm not doing something clockwork. Could tell you that. Ooh, stepper motors. Look at that. Beauty. Let's see if we can design something. Okay, be quiet, GeForce. This is not a video game. Create new. Okay, all right. So let's see if we can make a sketch. Now, is it a draft or a drawing? I don't know. Part workbench? Let's see. Extrude, no. I think you need a drawing first. So let's go draft. This looks a little bit like Fusion. Okay, go to the top. Okay. All right, B-dubs, I'll probably be here, probably for another hour or so. Until my throat can't handle it anymore. All right, let's build something. Yeah, no, I get that, Thomas, but it's still not like beginner friendly. You still have to have like an electronics mindset to kind of kind of deal with it. Okay, let's see. So let's make, okay, hang on, let's go webcam. Let's try to make a case for this thing. Right, so I need a couple openings. I'd like this to clip in to the bottom. So let's take a couple basic measurements. I actually have some other ones. Come on, focus. There we go. I have some other ones I can take design cues from. All right, so what was it? Power and regulators. In the power/regulators bin. Oh, what kind of dog do you have, Adam? A bracket for that big electric motor. Well, it has a bracket. See, down there. What I would need is to adapt it to a bracket to fit my outboard. I don't have my outboard in the house, and it just snowed 20 centimeters, so I'm not going outside today. I'm gonna go shovel when the whole crap show is over tomorrow. So, I like your thinking, but I'm not going outside today to pick up the motor. Although it would be funny for you guys listening to my struggle. Which view to start? It's not Blender, but it comes close. Yeah, I get you. I need to do a tutorial series. I did a tutorial series on KiCad, but I can do another one. And I do need to learn FreeCAD enough to do a tutorial. Okay, so what do we have for width? So it will be 45.3. So that is not part of this. So 45.3 by oops, that was already this. So it's not 45.3. Oh, it is. What's going on here? Yeah, 45.3. And this side. Tough part is lining it up by 60. Okay, so that's for the base. I need it a depth to clear the components, you know, somewhere around 2 mils, probably more. Let's see, about 3 mils. Then about, let's go 4 mils. Give it some breathing space down there. And then what we need, our overall case needs to be bigger. So at least 53, and then room for the cords. So let's say 75. So let's go 55 by 75. And then we need the overall height. You know, if we add those 3 mils, probably we need enough space to clear the, let's give it a good, go 50 mils. Oops, 50 millimeters. There we go. So let's try that. Try to build a case for this. We can do center to center bolt pattern here. 330. So 50 mils plus 330, so that's 53.3 by 36.56. and that'll be the hole sizes. Oh, and then 3.3 holes. All right, that should be enough basic measurements to get us started. So let's get that started. Canada is both. So sorry, I don't have an answer for you. So basically, things like weight of small things like grocery items, it'll be in grams. But my personal weight, I don't know it in kilograms. It is, yeah, we know them in pounds. So it's like both. Distance on the road is kilometers, but height is feet. And yeah, feet and inches. So yeah, I don't know. What's filled? I don't know. Whatever. Let's figure this out. All right. So, can I snap? Utilities. Oh boy. Is there snapping? Measure distance. Auto group. Edit. Join. Okay. Okay, what's lock? Snap lock on. Snap lock on. Snap endpoint. Midpoint. Center. Oh. Angle. Oh, you can toggle these things on and off. Okay. Hang on. Snap parallel, snap special, perpendicular, extension, ortho. Is this snap to grid? Snap dimensions. Oh, that's on and off. Snap to grid. On, baby. All right, we can do this. Okay, so X changes, Y changes. Okay, so we need, let's say our outside case has about 2mm walls. I think I might just extrude the walls. So 55 by 75. No, let's add 2 mils to that. So 57 mils by 77 mils. And 0 mil. Oh no. Okay. So that didn't save. That is not good. Okay, so let's snap to dimension, probably. Snap dimensions. Okay, let's try that. All right, so make a rectangle, snap to the origin. Okay, I like it. So 57 by 77. And now, no, it's not snapping. 57 by 77. Enter. No. Okay, how about if we finish it and then we edit it? Rectangle, yeah? Yes, there's a rectangle. Height 57, right? 57 by 77. I don't know what the hell what happened there. Why is this so big? Okay, whatever had snapped doesn't snap anymore. Can you move this? Had to provide the wrong measurements this week for a stair lift. Who in their sane mind doesn't use metric standard for measurements in the UK? Yeah, construction here is very much standard as well. Imperial, I should say. Okay. Okay. Why? What is going on? Okay, well, anyway, didn't I snap to origin? I thought it snapped to the grid. Is this on the origin? That's not even, that's not anywhere. Okay. Delete. This is, maybe it's not draft. Maybe I should just go right to the part design. I don't know what the difference is between part design and part. Pad. No. Datum line, whatever that means. Oh, is this a sketch? Create a sketch. This is what I wanted. Create a sketch. The XY plane. Here we go. Here we go. It's getting warm now. It's getting warmer. All right, snap this to the origin, right? Do we have snapping again? So now my question is, why wouldn't I have the same snapping options when I'm working on a sketch? Why Windows? No. Constraints? Not constraints, I want snapping. Tools. Okay. I found the snapping in one workspace, but there's no snapping in this other workspace. I just go there? Okay. Can I tab? Oh, come on. Really? Okay, so I've got these. Can I? What is going on here? Can I edit this? Edit. Okay. Normal. Good. Length constraint. Okay. All right. Here we go. So we're going to go 77 millimeters. Okay, we got this. How? K and D. K. D. Insert length. Okay. 57 millimeters. Okay, so we got a rectangle. Yeah, you're telling me. So here we are. How long has it been now? 20 minutes, and we have a rectangle. Phenomenal. Okay, close. Uh-oh. No. Bring me back to the sketch. Oh, mofo. Sketcher. Model. Sketch. Oh, sketch. Okay, we're back in the sketch. All right, one more. Oh, all right. So if I want 2 millimeter walls, oh, I have no snapping. Snap to there. There. Okay. Just gonna make it like this. Okay. This. D. No. K. No. How do you? K. Right click. No. So what? 6th line. K. No. D. Oh, D. Okay. Yeah, this is difficult. I mean, there's a massive learning curve, but the thing is, I am relatively proficient in Fusion, and I am Like, look how lost I am in this. All right. What length was this again that I wanted? This was 55. 55. No, oh, I didn't stay in the corner. Why? Why wouldn't you just let me pop it there? Oh, you bastard. All right. D. No. K. No. So how come D works sometimes? D, but not other times? I don't know. So that's 55. This will be 75. Okay. Okay. Got this. Difference of 2 cube is done. Okay. Okay. All right. Now let's see what happens if I make a line, right, between this and this. No, I want exactly, can I not snap to 90 degrees? Okay, okay, line. I can change this to a construction line. Oh, all. You change this to, how do you convert it to a construction line? Toggle G or N. Okay, so now it should be a construction line, right? Yeah. Okay, it's a construction line. And then D. No. D. D. K. K. Okay, that doesn't work. Length constraint. See, it says K or D, but whatever. All right, 2 millimeters. Actually, it'll be negative 2 millimeters. Okay, fine. Length, 2 millimeters. Okay, so that worked. But now it's above. I want it below. Why can't I say other? Okay, whatever. Okay, line. Can I just convert it to whatever? Okay, from this to this, I want exactly 180 degrees. All right, good. To convert this to construction. Okay, all right, good. Length constraint, 2 millimeters. Okay, so now, good, but how do we, if I can't do a negative constraint, then how do we, can draw by hand faster. Yeah. This is not, folks, this is not going well. I'm gonna be honest here. FreeCAD is not going well. Tools. Customize? Can I just tell it to just work like, is there any way I could just tell it to be more like Fusion 360? Can you, let's see. Can you program FreeCAD in such a way that it feels more like Fusion 360? Let's see. No. Asking I don't, you know what? I stopped watching AVE's videos quite a long time ago now. In fact, I can probably pinpoint it very accurately if I tried. I just want... Yeah, I used to be thoroughly entertained by AVE, but he took some fairly radical points of views. So I'm over it, basically. Can we just... So I can't do this negative. Can I? Okay, maybe it's not aligned. Okay, hold on a sec here. Maybe I can just delete this and like delete this, because maybe that's not what I need. I need to just space these apart. So it's like this and this. Can I make it? Oh my God. This? No, what are you doing? Okay, which line? Okay, 8 line. Let's go horizontal distance. To what though? Let's say -2 millimeters. Okay. Yeah, okay. All right, Thomas. Hopefully I didn't scare you away with the AVE talk. So, yeah, this is a nightmare. I mean, there's definitely something I'm doing wrong. But this is horrible. Discard. Okay, let's see how... Anybody have a timer? Let's see how fast... New. Let's see how fast I can do this, all right? So here we go. Let's create a sketch on this plane. Watch how much easier this is. So I wanted this to be 77 by 57. Like so, and then I can make another one. Even zoom in, can go 2 mils in, and that would be 75 by 55. Oh, that's not 2 millimeter walls. Okay, see I made a mistake. So 70, 7, 8, 9, 79 by 59. And then 55, yeah, so that's good. We can actually add a constraint if we want to. Inspect. No, actually, you could just do this. So look, X. From this line to this line. And then that's good. Oops. Go back to your sketch. You can actually sketch dimensions if you want to, but it's not actually necessary. We're not turning anything. All right, so that's the full length. Now we need to hold the board, which is, the board is 45.3 by 60. 45.3 by 60. So let's just make a center line here as a construction line. Right here. lock that to 90 degrees, like so. And then we can make a center rectangle. That's actually not what I wanted. Let's actually delete this and try again. Construction line, there, there. Then we get a 2-point rectangle right in the middle. And we want this to be 45.3 by 60. Oops, that would be 60 by 45.3. So that is the height. That's the height of, that's the actual size of the board, and it's pretty well centered. So that's good. And then we can add little dimples on it after. Do we want to round the corners? Sure, why not? Let's just round the corners. Whoops, not that. This. Add a fillet here. Let's say about 1.5. That's good. So there, and there, and there, and there, and there, and there, and there. I think that's pretty good. Let's finish this sketch. Now we're going to grab everything, this, and this, and we're going to extrude it up, let's say 2 mils to have a nice thick base. Bring back the sketch. Grab this thing and bring it up. Extrude 2 mils plus 4, 6 mils. And we're going to join like so, and then we're going to grab this and we're going to extrude 2 mils plus 6 mils plus 50, so that's 58. So we're going to go 58, and we're going to join it. Okay, we can, and here we have the basic box shape already that the thing's going to sit in. So that doesn't take long at all to do. And then we can even, you know, hook underneath the holes if we really want to. But yeah, this is like super simple as compared to FreeCAD, and you can see it's like freaking seconds. It's like literally 5 minutes to get this far, and all I have to do now is finick with little things to prop up the board, little screw holes, or probably just clips to clip it in. We make little holes on the side by making sketches on the sides. Like, this is just super simple stuff. So let's make little clips then. So we can clip onto the PCB. We can clip them like in the corners here. We'll just have them clip into the corners. So let's make a sketch here. So let's create a sketch on this. And let's make a little bit of a extrusion from here. So let's say, it doesn't have to be super big, maybe like 6 millimeters in each direction. So let's say 6, like so. That doesn't have to be a construction line. And 6, like so, and then have these come out maybe like 3 millimeters, like so, and then have this come out 3 millimeters, like so, and then yeah, like so. like so. Whoops, did I make a mistake here? 6 and 6, 3 and 3. No, I think it's equal. I think what you're seeing is that these things being inside makes it a little hard to see it's symmetrical. It's definitely symmetrical. Okay, now we're going to grab a line. And this can be a construction line to there, and there, to there, and then we can mirror the part. Grab all this part, mirror line here and here. Do you not mirror both? No, just one. Okay, mirrored. Then grab this part again, and this part, and then mirror. Grab the mirror line to be there. Okay, and now we got our parts. Finish the sketch. Grab these two. Extrude. Let's go -1. There we go. So that's done. And then grab the bottoms. That's going to be hard to do. You fell asleep. That's not good. And I know there's a way to view this as a wire mesh. That's the whole body. But what I usually do, because I'm lazy, I just take this and then just extrude it away and then come back to it later. So I can grab this, or these two I should say. The bottom icon menus. Oh. What am I, some sort of genius? Nope. And then if I press pull the corners, no. Where's the, oh, there it is. There we go. So the 3D printer will be able to print that at a 45-degree angle. So that's good. And then we'll get the sketch back, grab this and extrude 2 mils. There we go. That's back in place. Get rid of that. Oops. There we go. So that'll sit on that. And now we just need little clips around the edges, and then that's going to hold our box in. Oh yeah, I'm designing a case for a 3D printed case for a battery maintainer, which nearly anybody should be able to build for themselves, which is great. Tired of seeing people with, you know, batteries that are dead on their cars. And then clip to the sides. I don't want to make clips. Maybe I won't even bother making clips. Maybe I'll, yeah. Maybe I will. So where do I clip now? Because I kind of wanted it to be here. Make a sketch, grab this guy. And let's make ourselves our rectangle, 2-point rectangle with the center dot. Go right in the middle. And then center here. There. And then here. Should be able to grab both those. Yeah, there we go. There's my rectangle, and then I can make the clips go here. some way of storing the cables. Storing the cables I can build on the outside, so that's not a bad idea. Leaking tire with 3D print. No, I don't think so. Not that I know of. Okay, and now I need to design something that's relatively weak that will hang on to the edge of the board. So let's see. Maybe... Actually, I don't know if it has to be super weak. We'll have to figure it out. So let's make, let's say, that. And then really this to be 1.35. I don't remember how big this other one was. Well, and it's 2 mils from the corner. So, 4.8. Sure. All right, so we got these. Oh, excuse me. All right, and check the top again. Grab these two. And then, oh yeah, I should probably make some mirroring lines. Here to here. Make that a construction line, and then here to, oops, I should have actually made it from the outside. Here to here, make that a construction line. So grab this, and then mirror them over, oops, select. Mirror them over this way. Put the side going flat on top. Oh yeah, that makes sense. Cannonball Run was named after the man who set the first record for the Cannonball Run. Interesting. So that, and then grab the same geometry and this, and then mirror to there. Okay. Finish sketch. And now I want to extrude these up. Probably about 3 millimeters. Extrude, go 3. Typical PCB is 1.6 millimeters. Oh, you know what? They're probably going to be too close. Nah, screw it. Usually you want to give yourself 0.1 mils on both sides, but maybe I'll just extrude these back minus 0.1. And these guys as well, this and this. Extrude. Let's go minus 0.1. What I learned from a live stream is that those dialog boxes I'm using to extrude, they take math equations as well. Negative 0.1. There we go. Okay, and then I don't know if I can copy a feature from one to the other. I don't know. So let's try to create a sketch on here. This will be difficult to do. All right, so take a line. You're gonna go up 2 mils, like so. 2-point rectangle. Actually, I guess since it's 3 mils, I could just go by 1 mil. 4x8 is good. That, and then this can be here. This is what I'm trying to do here. I'm gonna take this, gonna extrude it by 1 mil. Like so. And then just fill, actually it's 0.5 mil probably. 0.5. And then all I have to do is fill that bottom void there. I really need that wireframe view. So this, display settings, visual style, wireframe. There we go. Can I grab that wireframe piece underneath there? I can't, still can't grab it. It's actually very difficult. You can slice actually through the view. Effects, environment, visual style. So there's the, okay, that's the regular one. Oh, actually, no, it looks terrible. Okay, hidden edges. Can I want to select the hidden edge? No. So, okay, that's the regular style, like that. I want that one line underneath. But there's a way to make like a cut as well. Inspect. Section analysis, that it? Can I reach it now? No. Well, I'll tell you what I can do. This is 59 or whatever. There we go. I can work on it and then make the walls after. Oh, is there a way? Oh my God. There we go. I got it. All right, and then I want to do this, a chamfer, like that. And then if I chamfer this one, chamfer, I don't remember how much a chamfer it was. Probably like that. So there we go. That'll clip it in. So now I want to take all this and duplicate it. So yeah, you can definitely do that. Maybe I'll just print this piece as well once it's done, just to make sure it clips in. But yeah, that's the plan, is to do this with the clips, and then you can just, clip your board in, and then you don't have to use screws, because the less hardware people have to buy, the better, I think, at least. I like that. I like that. I just don't feel like replicating it a couple times. Maybe if I slice it on this and then just duplicate it. Let's see. Can I do that? I think you can do that. If you modify, right? Well, split body. Body to split. Splitting tool would be this face. Okay, now this should be separate. Body 1, 2, 3, 4, 5, 7, 8, 9. So body 9. Okay, all right. So this body is body 2. If I delete it, oh, remove. Okay, so grab body 9, and then I move copy, create copy, and I can just shift it over here. There we go. No duplication for me. Like that. Then I can delete all these bodies. Remove. 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 This is a way better way to do things. Remove. And one has to stay. Okay. So if I grab body 9 and 10 and I go move copy, I'm gonna create copy, move them forward till they're in the right spot. Okay, whatever. And I flip them 90 degrees or 180 degrees. Move them this way. I'm almost done anyways, Franco. Okay, still need to get this enough space. That's good. This, and then another 0.1. That should be good there. Make sure the other side is good. Yep. There we go. Take body 12. We're going to move copy. Create a copy. I'm going to flip it 90 degrees. The other way. We're going to move it into place. Just so it's lined up here. Like that. Line it up here and another 0.1. Like so. And then we're going to move copy this. Look at these skills. That's good and lined up. Now we need 14 and 13. We're going to move, create copy, and we're going to rotate it 180 degrees. We're going to move them, and we're going to move them. All right, move them into place like that. More, and then we need to line them up this way, and then another 0.1. There we go. That was much easier. All right, I think I'm going to end it here because it is 4 o'clock. I'm going to eat at some point. But yeah, I'll end it here, and now I'll print this. Oh, I need to. Hang on a sec. Need to turn something into read only because I can't save. LED. Read only. Make read only. And go home. New project. Charger case. All right, and then we can save this one here. Charger case in charger case. Save it. There we go. So this is where it ends, but I will print this, and I'll see if it works. Sorry about my cough. I might be slightly dying. Who knows? And then, yeah, I'll probably continue this on the next stream. Next stream is not going to be Saturday. I think my wife is streaming that Saturday. And so, yeah, just, stay tuned, and I will post when I'm going live. Thank you, everyone, for being here. Thanks for watching.